Hello everyone, in this video we will dive into bidirectional encoder representations from transformers or BERT. It is from this paper published in 2019 by Devlin et al. Transformer consists of encoder and decoder, designed for machine translation. However, we want the model can be used for other purposes, such as classifications. BERT consists only of the encoder without decoder. The word bidirectional in BERT means the model can see two directions to future and past words using self-attention. BERT also introduces a new token, classification token, which is learnable. One example of task that can use the classification token is sentence classification, such as spam or not, or good, neutral, bad sentiment. The classification model is placed after the classification token. This class token will aggregate the information from the whole input using the self-attention. It is technically possible to not use classification token and average all of other output features for classification. However, since class token attend other tokens using self-attention, the model can focus or ignore some part of the input. BERT training consists of two stages. First stage, the self-supervised learning part, where we train the encoder using a pretext task. Second stage, using the pre-trained encoder, we add task-specific model for the downstream task on top of the encoder, such as the classification layer. The fine-tune can be only on the task-specific model or the whole model, including the encoder. There can be many kinds of pretext tasks that we can use to train the encoder on the first stage. One example is mask language model. Given this input, some of them are becoming hidden and so changed to mask token. BERT paper mentioned they mask 15% of the input. For the mask token output feature, we have word classification layer, so the model has to guess what is the masked word. Training like this will let the model learn to see context. Besides masking, the word can be changed to other words, or even not changed. Why we need the unchanged input too? So the model does not learn the shortcut that if the input is word A, then the prediction is definitely not A. Instead of properly see the context, what should be the output. Another example of pretext task is next sentence prediction. For example, we have two sentences input separated by separator token in the encoder. Then classification whether the first sentence is connected with the second sentence. We train like this so the model learns to see the connection between first and second sentence. A good example of downstream task using this pre-training model is question answering. The question can be in the first sentence, and we can try different answers in the second sentence and see which question and answer pairs are correct. Another new thing in BERT is segment embedding. So the input consists of word embedding, position embedding, and segment embedding. Segment embedding is like positional embedding, but for sentence. In which sentence is this word located? Every word in the first sentence will have the same segment embedding.